For this activity, you'll be picking the scenario showing the smaller effect size. Effect size is the number of standard deviations that the sample mean is away from the population mean. On the right, we can see Cohen's d. That's one way to measure effect size. And so Cohen's d of 0.8 lets us know that there's 0.8 standard deviations that the sample mean is away from the population mean. On the left, we see the visual representation. In blue is the histogram for the data. In solid red here is the null hypothesis distribution. And we can see that the sample mean is about a half of a standard deviation above the population mean. So when choosing between a Cohen's d of 0.5 and a Cohen's d of 0.8, we're going to pick the smaller effect size, so we'll pick the card on the left. Okay, so now in this next set of scenarios, on the left, the data matches up really closely with the null hypothesis distribution. So there we consider it to be a very small effect size. On the right, we can see that the sample mean is again about a half a standard deviation above the population mean. So that'd be like a Cohen's d of 0.5. So picking the smaller effect size, we'll click the scenario on the left. Okay, now we're shown that the effect size is small, so a Cohen's d of 0.2. And on the right, again, we're seeing a sample mean a little bit more than half a standard deviation above the population mean. And in choosing between the two, we'll select the Cohen's d of 0.2. When we measure effect size using Cohen's d, one kind of easy rule of thumb for interpreting Cohen's d is that a Cohen's d of 0.2 is considered a small effect, a Cohen's d of 0.5 would be a medium effect, and a Cohen's d of 0.8 would be a large effect. Now this can be influenced by a particular area of research, what they consider small, medium, and large, but absent of that, 0.2, 0.5, and 0.8 are the typical breakpoints for whether the effect size is small, medium, or large. Okay, looking at this set of scenarios, the sample mean for the scenario on the left is about 1.3 standard deviations above the mean, so Cohen's d of 1.3. And for the scenario on the right, it's about a half a standard deviation above the population mean. So the scenario on the right would be our smaller effect size. Sometimes if you don't want to just visually eyeball it, you could also use your calculator and calculate the Cohen's d. You would take the sample mean of 128.19, subtract from it the population mean of 114, and then divide it by the population standard deviation of 16. Looking at visually, in this case the sample mean is about 1 standard deviation above the population mean, so about Cohen's d of 1, versus the scenario on the right, a Cohen's d of 0.2. So we picked the scenario on the right as being the smaller of the effect sizes. And so just using that logic, you can go through and complete the activity. And there we go. Good luck.